today's episode of my class, I'll be taking you on alkanol or alcohols. Because alkanol is the IUPAC name, while alcohol is your trivial name, named from the source. You are the IUPAC, you are the trivial name. Now let's start with the definition. What is an alkanol? So just like my foundation of organic chemistry, you see that organic chemistry is split into hydrocarbon and non-hydrocarbon compounds. So alkanol are the non-hydrocarbon organic compound with OH as its functionality group. OH as its functionality, that is functional group. Functional group with OH as its functional group. What is the functional group? When we look at functional group, we are referring to that part of an organic compound where most of its chemical reactions do occur. Most of its chemical reactions. But this does not imply that maybe functional group is not also in charge of the physical activities of the compound. So it is proper to put it that functional group is that part of a molecule that is in charge of the physiochemical reaction of the particular compound or in question. Yes. So OH is functional group of anything called alcohol. And alcohol we have aliphatic alcohol. We also have aromatic alcohol, like phenol being the most prominent example. So we have aliphatic alcohol. Aliphatic alcohol. Aliphatic alcohol. Of course, I'll be using the name interchangeably. I told you you are trivia name, trivia meaning name, own name. You are IUPAC. IUPAC. So aliphatic alcohol have the general molecular formula of CN H2N plus 1 OH. So that's the general molecular formula of aliphatic alcohol. That's why at times they present functional group as ROH. So this is the why this is the aliphatic part of it. R is the aliphatic. So this formula can also be ROH. So that is it. OH is the functional group of alcohol. So when we talk about the, of course, aliphatic alcohol, there are many in number. We have methanol, we have ethanol, propanol, butanol, pentanol, hexanol, hexanol, heptanol, octanol, nonanol, decanol, undecanol, dodecanol, tridecanol, etc. There are much. 20 carbon atom of alcohol is called icosanol. Then icosanol, docosanol, till you get to 100, which is heptanol. Now look at this. Look at this. Just follow me squarely so that you understand every bit of this. And you look at this particular one is for aliphatic alcohol. Now, but when we talk about aromatic alcohol, aromatic alcohol now, aromatic alcohol, we are having symbolizing it as AROH. They are standing for aryl or phenyl group. Of course, the same thing. R here stands for alkyl group. That is a group gotten by loss of one hydrogen atom from the parent alkyl group. While AR here is aromatic, it signifies aromatic group, which stands for aryl. This one is alkyl. Of course, this one is aryl or phenyl. And phenyl, this is a group gotten by the loss of one hydrogen atom from the parent benzene. So that is it. So it is acting as a radical here and all that. So that is aliphatic. So benzanol, or what example of this aliphatic alcohol is what we call benzanol. Benzenol or phenol. So that is it. This is it. Let me use this one. That is benzenol or what we call phenol. So that is all about the basic thing that you need to know under this compound called alkanol. So let's talk about classification. I'm going to be classifying alkanol into two different groups. Before we continue with classification, let me see, just like I give the formula of this. The formula of aromatic alcohol is going to be CnH2n minus 7OH. So that is the general formula of that alcohol. That's the formula for aromatic alcohol. Now, from classification, like I said, we are going to be considering classification based on the number of hydroxyl group and then carbon. So I want us to take, based on the number, classification of alcohol or alkanol. Alkanol. One is based on the numbers of OH group present. So with this particular one, we are going to have what we call monohydric alcohol. Monohydric alcohol, and these are those alcohols. Monohydric alcohol, these are those alcohol that contain only one OH functional group. They contain only one OH functional group. One OH. So that is those alcohol that contain only one OH functional group. Example of this monohydrate can be, CH3OH, which we call methanol. You can see it's only one OH. It can also be CH3CH2OH. You see one OH, that is ethanol. It can be CH2OH, which is propanol. So far as it contains one OH, you fall under the class of monohydric alcohol. Then the second one, based on this, is what we call dihydric alcohol. Dihydric alcohol. Just like the name mono means one. Then monohydric, one OH functional group present in the organic compound, the presenting alcohol. Here, dihydric means two. That means going to be two OH functional group present. And with this, the most prominent example that every exam like asking, example, please take note of this, very important, is ethylene glycol. Ethylene glycol, that is an old name. And the IUPAC name of this is ethane 1,2-diol. Ethane 1,2-diol. So that is IUPAC name of ethylene glycol. That is a good example of what we call dihydric alcohol. Then we go to the third one. The third one is number 3 under this classification is trihydric alcohol. Trihydric alcohol. These are those alcohol that contain 3 OH functional group. They contain 3 OH functional group. And of course, the most prominent example here is glycerol. Glycerol have an IUPAC name of propan 1,2,3-triol. So let me give you the structure of this. You can put it this way. OH. That is the structure. Of course, you can put it this way. CH2OH. So that is it. This is the structure here. That is the structure. OH will be in all the carbons. There are 3 OH. So that is it. Or you can put it this way. You can put it CH2OH. CH2OH. That is what we call trihydric alcohol. Trihydric alcohol. We have 1 mono, 2 di, 3 try. Classifying alcohol based on carbon position. Please, before this, I want us to address type of carbon atom. We are going to consider first. First, we will consider type of carbon atom. Types of carbon atom. Carbon atom. Carbon atom. You of course need to understand that carbon is so important in organic chemistry. Very, very important. One, we talk about the its ability to form multiplicity of bonds with itself and other elements, which is specially termed catenation. Again, you talk about the position of carbon in the periodic table, and carbon is position in the second row in the periodic table, and the position in the middle of the second row. The position in found carbon atom is in such a way that the element to the left hand side of the carbon, when you face your periodic table, element to the left hand side of the carbon have the propensity to do what? Donate electron. And these are your metals. You know metals as a good electron donor. Whereas the element to the right hand side of the carbon have the propensity to accept electron. And these are the non-metals, which you know they have the characteristic tendency to accept electron. That's why we say metals are good electron acceptors, whereas non-metals are good electron donor. So type of carbon atom. Under type of carbon atom, we are having number one under this, number one A, or let me number with alphabet, is primary carbon. Primary carbon. Primary carbon. Primary carbon. What is a primary carbon? A primary carbon is that carbon atom that has only but one other carbon directly attached to it. Directly attached. Look at this. I will be symbolizing primary carbon. The symbol of primary carbon is 1 degree. Let me use that for primary carbon. 1 degree. So primary carbon, look at this. Look at this. Look at this. Look at this. Good. Now any carbon I put asterisk. So that is the primary. This is it. You are a primary carbon, you are a primary. What makes you a primary carbon? Because only this carbon that is directly attached to you. Only this particular carbon, this carbon that is directly attached to you. So you are a primary carbon. You are 1 degree. You are 1 degree. You are also 1 degree. So that is it. A carbon that have one other carbon atom directly attached to it is said to be primary carbon. So when you go to the B part, secondary carbon, secondary carbon, designated as 2 degree. A secondary carbon is a carbon atom that have 2 other carbon directly attached to it. So let's go by the same this thing I did here. You see here, see anyone I put asterisk. So here you are leaving U. When we talk about this carbon, U and U is attached to it, so you are a secondary carbon. Even U and U is attached to it, so you are also a secondary carbon. So that is secondary carbon. A carbon atom that is attached, that 2 other carbon atoms is attached to, is said to be what? Secondary carbon. Now let's also look at the third one, which we call tertiary carbon. Tertiary carbon. A tertiary carbon. Tertiary carbon atom. What is a tertiary carbon atom? Designated at 3 degree. A tertiary carbon is that carbon atom that has 3 other carbons directly attached to it. Example, you have something like this. So this is a tertiary carbon. That is 3 degree. You are attached to it, you are attached to it, you are attached to it. You are a tertiary carbon. That is 3 degree. Then we talk about the fourth one, the D, that is quaternary carbon. Quaternary carbon. Quaternary carbon. Quaternary carbon is that carbon atom that has 4 other carbon atoms attached to it. The example of quaternary carbon, you have something like this. You have something like this. So this carbon is quaternary, that is 4 degree. Quaternary, we have quaternary carbon, but we don't have quaternary alcohol because carbon is tetravalent in nature. So there is no other space for attachment of OH. So we have, that is why we don't have quaternary alcohol. Quaternary carbon is being attached. That is why when you have an alkane, example, we have an alkane that is attached by 4 things like C, CH3, CH3, and CH3 here, and CH3 here. We call it neoalkane. Neoalkane. This one is neopentane. Neoalkane. That is neopentane.